8.3, Intro to Complex Numbers. So this is our first day looking at complex numbers. We're going to look at the definition of complex numbers and then just play a little bit with simplifying. So first, about pure imaginary numbers. I have written there exists a non-real number I such that the square root of -1 equals I and I squared equals -1. So let's think about where that I squared equals -1 comes from. So I'm going to start out by writing I equals the square root of -1, and then I wanted to think about squaring both sides of that. So if I have the square root of -1 and then I square it, my square root and my square are just going to make a -1. So that's where that comes from. If a is a positive real number, then if I have the square root of -a, I can make it the square root of a times the square root of -1, and then I can substitute I for that square root of -1. So think about all those times when you were working out a problem, say the quadratic formula, and you came across the square root of a negative and you would write no real solution. Today we're going to look at how to express those answers as imaginary numbers instead. So we won't write no real solution anymore. Now we can actually come up with solutions. They're just imaginary. So for a, it's the square root of -4. So I'm going to write that as the square root of 4 times the square root of -1. And then the square root of 4 is 2. Square root of -1 is I. So we have 2I. We'll do the same thing on the next one. And you probably could just write down the answer right away on this. Square root of 100 times square root of -1. So that'll be 10I. There's no even root of 20, but I could make it square root of 4, square root of 5, square root of -1. So that will be 2 square roots of 5 times I. Be really careful that your square root does not go over the I. Sometimes books will write that as 2I square root 5, and I think it's for exactly that reason. They're worried about you extending that square root across over the I, and the I does not have a square root above it. On the last one with 24, we would use 4 and 6. And the square root of 4 is 2. So we have 2 square roots of 6I. Or again, we could write 2I square roots of 6. And again, I've just seen that both ways depending on the textbook. Oh, goodness. We are moving our math around, which we really don't want to do. So let me scroll back up, see if I can get that to move or erase it. Every time I learn something new on this, I also learn how to make more mistakes. I do say in the middle here that if we have a pure imaginary number, it's the form ki, where k is real and non-zero, so think constant. So 6I is imaginary, square root of 5I, negative 12.5I. So it could be a fraction or a decimal or even a square root. The big thing is that we have a constant times I. So now we want to think about what properties they follow. So if I solve using properties of radicals, square root of 9 times square root of 4 is square root of 9 times 4, which is 36, which is just 6. So let's see if we get the same thing doing imaginary numbers. So with our definition of imaginary numbers, we would first write square root of 9 square root of -1 times square root of 4 square root of -1. So this would be 3I times 2I, which would be 6I squared, which is 6 times -1, or -6. So our conclusion is that they don't really follow those same properties until I factor out that -1 first. So we need to use definition of imaginary numbers. To factor out I first, otherwise they don't work. Out I first. And again, this is in my own words. You guys know that I do that a lot. Try to put things in my own words instead of math definition words. So we really have to factor out that I. And then after we do that and kind of separate it, then we can go on working with square roots. So if I am looking at 2a, I'm going to make this one square root of 2, square root of -1, square root of 8, square root of -1. 2 and 8, I can multiply those and get 16. And then I would have an I times another I. So 4I squared, which we know is negative 4. So I feel like I've shown this in the longest way work possible. You do not need to write, once you kind of get used to the substituting square root of negative 1 for I don't need to see this step anymore. You could go directly to I. On the next one, I'm going to make this the square root of 4/9 times the square root of negative 1, and that'll be 2/3 I. On the next one, I can divide this. 54 divided by 6 would be square root of a negative 9. And hopefully by now you look at this and you're like, oh, 3I. Square root of 9 is 3, and then if I have a negative, I would have an I in there. For 3a, we can add our i's just like we would variables. 2 plus 5 is 7. Minus 9 would be negative 2I. On b, I'm multiplying, so 5 times negative 5 would be negative 25I squared, or negative 25 times negative 1. So we'll have positive 25. And then on C, first I would look at simplifying each of those square roots separately. And then remember, we do have a minus sign. So we'll have 4I minus 3I. Then we subtract them and get I. So we're doing just really basic simplifying today. So for 4, we need to, I think the directions were simplify or solve. We did a bunch of simplify. This must be solve. So there are different ways of solving this. I cannot factor. So my choices are completing the square or quadratic formula. So if given that option, I'm always going to choose to complete the square. It's just faster and easier for me. So first I need to subtract 16 on both sides. So I have x squared plus 6x equals negative 16. And then I think about what I need to complete the square. So if I wanted to have x squared plus 6x plus something so that I have a perfect square, I would take 6 and divide by 2 and then square it. 6 divided by 2 is 3, and 3 squared would be 9. So I'm going to write x squared plus 6x plus 9. And if I add something on one side, we have to add it on the other. So negative 16 plus 9. So now I factor. This will give me the quantity x plus 3 squared. On the other side, negative 16 plus 9 is negative 7. And I'm out of space, so I'm going to go up over here. Let me rewrite it. And now, if I have a square, my inverse is going to be a square root. So let's go ahead and do that on both sides. The square and the root, in this order, if I have the square happen first, that means I don't know if I squared a positive or a negative thing. So I need to have an absolute value of x plus 3. And on the other side, and that x is really ugly, I don't know if that's better or worse. This definitely looks like an x now. On the other side, I have the square root of 7. And because it was negative, I'm going to put an I there. So I essentially just factored out that square root of negative 1 and made it an I. So then x plus 3 will equal plus or minus square root of 7I. And then I will subtract 3 on both sides. So x equals negative 3 plus or minus. Now we got to find our problem again. Square root of 7I. So next, just a little bit about vocab, and we'll review this again tomorrow. A number can be expressed in the form a plus bi, where a is the square root of negative 1 and a and b are real numbers, and that is a complex number. So complex numbers have a real part and an imaginary part. So my real part is a, my imaginary part is bi. We also have this thing called conjugates. So it says for every complex number, there exists another complex number called its conjugate. The conjugate of a plus bi is a minus bi. So we change the sign on the imaginary part to find the conjugate. And these are going to be really important tomorrow. So now I need to scroll up again. So we're going to fill out this table just looking at vocabulary. So if I have negative 6 plus 2i, my real part is the negative 6. My imaginary part is 2i. So it's pretty easy to pick out the imaginary part, right? It just has the I with it. So the conjugate means I change the sign on the imaginary part. So the real part will stay -6, and then instead of being a plus 2i, now I have a minus 2i. The next one, I don't have a real part, so I'm going to write 0. My imaginary part's -4i, conjugate would be a positive 4i. 10 is only a real part. The imaginary part is 0, and so the conjugate is just 10. I have no imaginary part to change the sign on. 5 minus 2i, real part is 5, imaginary is -2i, so conjugate I need to change to plus. And on the last one, I switched the order on you to trick you. It's really a -7 plus 3i, and so our real part is -7. 3i is imaginary, and the conjugate is -7 minus 3i. So we're going to look a little more at simplifying with fractions, and then we're also going to factor. So if I have an I in the denominator, I don't want it there. So by simplifying, what I mean is I need to multiply by I over I. And then in my numerator, I have 2i. My denominator is 3i squared. I think I'm going to have to go to the right now. So that would be 2i over 3 times -1, which is 2i divided by -3, which is just really -2/3 I. I feel like there was a lot of extra kind of steps in that problem, but I wanted it to be really clear what I was going through and doing. On B, I can divide the 8 by 2, but that I is in the denominator. So when I divide 8 by 2, I'm just still left with -4 over I. And then we need to do those same steps. We're going to multiply by I over I. And I'm doing that because I know if I have an I squared in my denominator, then I'll get a -1, and I won't have an I there anymore. So 4i over I squared. Again, I'm showing way more work than what I would really expect you to do, and I'm sorry that I am not moving vertically, but I'm out of space. Negative divided by negative would be a positive 4i. So factoring, I know it looks like we can't. There's a plus sign, but it turns out that we can factor over the set of complex numbers instead. So when I say over the set of complex numbers, I just really mean with I. So I'm going to first rewrite this as x squared minus -36. So remember in math, we're always looking, is each line equivalent to the last? And minus negative is the same thing as plus. So this is really x squared minus 36 times -1, because the -36 is the same thing as 36 times -1. So now I'm going to substitute, and instead of a -1, I'm going to write I squared. So now I can clearly see that I have x being squared, and then 36i squared is like 6i being squared. And so now I can write this. I have two squares with a minus sign in between, so I can do sum and difference of squares. So x plus 6i, or I have the difference of squares, so I can write this as a sum and difference, x minus 6i. So let's check out our last one. This is something where once you get good at these, you can go from A to your final answer. You can skip all the work steps. But when we're first doing them, especially in our notes, we want to have something to look back on. We want to remember why and how we did this. So x squared minus -64 is x squared minus 64 times -1. So remember, we changed a plus to a minus negative. Perfectly legal in math. The -64 we made into a 64 times -1. Now we're going to replace. We're going to let -1 equal I squared. We've been subbing that the other way around. We've been putting in a -1 for I squared. Now we're going to put an I squared in for -1. And then from here, I can go ahead and factor. I'll have x plus 8i times x minus 8i. So this is it for our complex numbers day 1. Please go to class and ask questions if you need help with anything.